Today we are going to discuss on refractories, especially that are used in direct iron reduction processes. As we all know, mainly three major DRI routes: coal-based, MIDREX, and hydrogen-based DRI. Now let us see why the refractory matters for DRI. As we know, it protects reactor from thermal, chemical and mechanical wear, and once there's wear and tear occurred in the refractory, then campion also reduced, and other way we can say that there is an interruption in production. So it is very important part. Now, what is the challenges in the coal-based DRI? As we can see that this coal-based DRI are based on coal primarily, and ash of the coal create a lot of accretion formation inside the kiln. So these accretion actually protect up to certain extent, but at the same time there is a inferior heat flow inside the kiln, and apart from that there is also a carbon deposition reaction which disintegrate such type of accretion, which create further problems for the kiln. Now coming to the vertical shaft MIDREX, where we come with the effect of two components, that is carbon monoxide and hydrogen. As hydrogen attack silica at a high temperature, and it create a porous structure, and that CO causes the carbon buildup, and this is how the hydrogen and CO in the MIDREX process affects a lot. Here we will focus especially with respect to hydrogen, how the effects occur, and as you can see that hydrogen react with the aluminosilicates at high temperature, and this hydrogen reduces silica, and due to this reduction of the silica, it leaves this silica comes in contact with the hydrogen to form a silica gas, and in process of formation of this silica gas, as it leaves, it forms a porous structure which becomes weak and could not able to sustain the load, lateral pressure of the body in the vessel, and finally result in a breakdown. So as it is already shown that the carbon monoxide actually helps especially in terms of carbon deposition reactions, and this carbon deposition in pores becomes a source of a stress and a strain later stages, which create a problem for refractory. Similarly, iron oxide, where iron also forms a catalytic component to enhance the reactions, which also disintegrate the refractory. Similarly, as we have already shown, the hydrogen and the S2O also the shift silica reaction backward. So one way we can say this S2O up to certain extent protect silica reactions, and the carbon monoxide and hydrogen together enhance the carbon deposition reaction, and they have a deeper damage. Now coming to the case of hydrogen DRI shaft. Here, as we can see in coal-based DRI plants, we don't have any ash, and so there is no accretion, and that's why, as accretion where gives protection in coal-based DRI, here that part is absent, and that's is the reason for more faster abrasion in hydrogen DRI. And as it is already explained, the high silica refractory get reduced by hydrogen, and create a lot of porous structure, and these porous structures becomes weaker, which could not able to take the load of lateral pressure of the pellets in the vertical shaft, and finally result in damage, generation of a hot spot, and improper heat flow across the wall. Hence, based on all this, if we come to uh, decide that what sort of our hydrogen shaft is to be fabricated with refractory, then our answer will be it should have a high alumina and low silica refractory as recommended, as shown in the slide. And one more important thing also, it is essential to know that the shotcrete is also very faster way to install, and it is a sort of a monolith single piece fabrication, not like a brick where we have a lot of joints and all those. So monoliths are going to substitute the bricks for a longer life, and this also gives a lesser breakdown opportunities, and hence more productive efficient running of vertical shaft. So our final thought is that in view of our processes, it is needed to select the proper refractory so that it suits the process. So the life of the refractory totally depends on the learning of processes. So hence, if refractory is compatible with the process, then life of the vertical shaft will long. Thank you.